Hi, we're just going to do a quick little review of common factoring and trinomial factoring, just to remind you of a couple of little interesting things. So here's an example of some common factoring. So just to quickly go through how this works. So again, you have an expression here, and the idea is to common factor. Now again, that is a reminder that you're looking for two numbers that multiply to 6, two numbers that multiply to 8, but you're looking for the numbers that they have in common. So I've got something called prime factors listed up the top. You can always try dividing each of your coefficients by these prime factors to see if that helps. You can also use any other factors, but as you can see, I've kind of set this up already. So the 6 can be written as 2 times 3. Now what you're hoping for is that when you come up with factors of 8, you also have something in common. And the ideal situation is to find a largest common factor. So as you can see here, the largest common factor happens to be the 2. So they both have the 2. That's why we're writing the 2 here as a common factor, and then the remaining portions, the 3x, don't forget the plus sign, and the 4 are the remaining factors. So as a double check, distributive property would mean take the 2, multiply by the 3x, which is what we have. Take the 2, multiplied by the positive 4, which is what we have. So here's your common factoring. If we make it a little bit more interesting up at the top here, then what we can see is that we're essentially going to have the same thing, except a little bit more complex, because now we have x squared in here. So what that's going to do is, instead of typing it as x squared, I'm going to write it as x times x, just to show you that there's actually 2 x's multiplied together, and there's an x over here. So how does that change the final result? Well, looking for the common elements now on both sides of the plus sign. So treat that as like a separator between the different terms. They both have a 2, but they both also have an x. So that means I'm going to have to modify my greatest common factor by adding in an x here. So what does that leave behind? Well, it leaves the 3 and an x, which I still have, plus sign, and the 4. So the dots are what was common, 2x, and then the uncommon parts, the 3 plus 4x. Okay, we'll try one more. So again, making this a little bit more complex. So now we've added in some y terms here. So not only do we have the x squared and the x, but now we have a total of 3 y's. I'm just going to get my cursor in the right spot here. So why is there 3 y's? Well, because it's y cubed. That's written as y times y times y. And then there's y squared here. So 2 y's. And as I talked about before, the quick trick would be to use the lower of the exponents. So you notice we have x to the power of 1 up in this example here, x to the power of 1, x to the power of 2. So the common factor included an x to the power of 1. So here, logically, it would be the same, because the x's are the same. And then for the y's, you would anticipate this to be the lower of the exponents, y to the power of 2. So let's see why this works the way it does. Well, again, on both sides of the plus sign, which is your separator, they both have the 2. The 3 is not common. There are 1x here, 1x there that they have in common. And then there's 2 y's that are in common. Just not liking that. I'll just do that instead. So you have a 2, one of the x's, x to the power of 1, and then y times y is y squared. And once again, leaving the remaining parts, 3, the x, don't forget the plus sign, and the 4 as your uncommon. remaining factor. Okay, so now taking a look at factoring trinomials when a is equal to 1. So just a reminder, what we have here is the standard form for a quadratic relation. If the a value is 1, then the way we're going to be taking a look at that is this format here. So this format will always factor to this look. Now, that's assuming there's no greatest common factor, okay, which we'll take a look at in a moment. And the way it works, the fast trick anyways, there are some other techniques, but this is a kind of a fast trick to getting this to work properly, is called a product and sum technique, where you look for two numbers that multiply, notice the brackets, to this, whatever the C value is, your constant, but then the same two numbers have to add to that B value. So we'll go through a couple of examples here just to show you how this works. So we're looking for two numbers that multiply to a positive 8, but add to a negative 9. So again, think of the numbers that multiply to 8. You can have 8 and 1, you can have 2 and 4. So you can try those, but the key thing is use the same numbers here and here. So these two, the 2 and the 4 will definitely multiply to 8, but will they add to a positive 9? No, they won't. So you have to do a little bit of a trial and error, but hopefully you can kind of surmise that the numbers you're really looking for are 8 and 1. Except you still have another problem. 8 and 1 do give you the positive 8, but 1 plus 9 do not give you the negative 9. Oops, sorry, that should be an 8. Do not give you the negative 9 that you're looking for. That gives you a positive 9. However, keeping in mind when you multiply two negatives, still get a positive. How does this help? Well, so now the two negatives here will produce the negative 9. So the expression you're looking for is bracket x minus 1. And we'll make it look a little bit better. Followed by x minus 8. And there's your factored form, just using the numbers that you have in your sum or product. Gonna make that, there we go. Move this little guy out of the way. All right. Okay, so one more example. So here, you notice the a value is not 1, but in this situation, we can make it a 1 because there's a greatest common factor. How do we know? Well, I can take the 2 and divide it evenly into 4 and evenly into 70, which gives me then 2 bracket x to the power of 2, take away 2x, take away 35. So what I essentially did there is I common factored the 2 through kind of a division process. And I've mentioned that before, where if you find something that's common, you can use a division process to get the remaining factors. So 2x squared divided by 2 is x squared. Negative 4x divided by 2 is negative 2x. And negative 70 divided by 2 is negative 35. So that's another way of thinking of your common factoring process. Okay? A little bit different than what I showed you a moment ago. So now what we're looking for is we need to keep that 2. But what's going to happen then is these three terms, this trinomial, is now going to produce this pattern again. Okay, so there we're going to have the x. So we're looking for two numbers that produce a product of 35. So actually, maybe we'll copy this, paste it down here, set this up a little bit better now. So the C value we have is negative 35, and the B value is a negative 2. So this is going to take a little bit more work. And again, you can always just do a trial and error. You should already know that 7 times 5 gives you 35, but we're looking for a negative here. So that's a starting point, but not an ending point. We're not done there, because we're looking at multiplying to a negative 35 and one negative 2. So one of these numbers is going to have to be negative to produce a negative. The trick is which one is going to be the right one to put the negative sign beside, so we get an answer of negative 2. And if you've already thought about that, yes, it is the negative here with the 7. So negative 7 and positive 5 is negative 35. Negative 7 plus 5 is negative 2. We found our numbers. So we are looking to put in the negative 7 here. Let's make that look a little bit better. And then we are looking to put, now notice, a convenient thing to do is once you've established what numbers you're using, never a bad idea to include the sign, because then you know exactly what to put inside the brackets. Hopefully this additional little video helps understand some of these concepts.